Hello there, children. Today we are going to work on our next section of math, section 3.6, solving equations, systems of equations with three variables. This educational experience is brought to you by your terrible vice president of three variables, that'd be me, Mr. Faust. So let's get cracking, shall we? So the first order of business here is to go to our set of problems and our rules. Here are the rules for solving using the linear combination method. We don't use substitution that much because it's really not super helpful for us. So, the linear combination method. So first, we're going to pick a variable we want to get rid of. Doesn't matter which one, just we try to pick the easiest one if possible. So, use the linear combination method to rewrite the system of equations. That's three equations and three variables as two equations, two variables. Because we know we can do that already. We're very adept at doing that. So that's our idea. Step one here, all it's going to say to do is take the three variables, get rid of a variable, and we're going to go after just two of them. And we're going to solve that system of two variables. And once we do that, we're going to substitute those values found in step two into the original problem. So step one, we eliminate a variable. Step two, we find the other two variables, what their values are. And step three, we substitute them back in to the original problem for the value, or to find the value that we eliminated in the first place. So what does that look like for us? Well, let's take a gander here. Alright, this problem. Ooh, man. I've got S's, T's, oh my. So what variable do I want to get rid of? First and foremost, as we talked about in class, you should always number these equations. That way you can tell someone, hey, here's what I'm doing. Alright, so what variable do I want to get rid of? I can either get rid of R's, get rid of S's, or T's. I'm going to get rid of S's because there's a -1, a 1, and a -2. They're very easy to get rid of. The R's making them look alike would cause a little bit of work, as would the T's. Not mathematically incorrect to do that, but just more time consuming. So what I'm going to do is I'm going to add equations 1 and equation 2 together. So what is equation 1? This equation right here. And add it to equation 2. And I add them up. Now, 2r plus 4r, 6r, 4t plus a -2t, 2t, and that gets me 28. Now, I've got to create another combination of equations here to get me going. What that means is I've got to pick another combination to get rid of S's. I don't want to get rid of any other variable at this point because that wouldn't be very helpful to me. I've got to get rid of the S's so I can have my equation only have two variables. If I don't get rid of the S's, get rid of, let's say, the T's or the R's, then I have two equations, but I'll still have three variables, and that's not very helpful to me. So I'm going to do equation 3 plus 2 times equation 2. Now, why am I multiplying equation 2 by 2? I can clearly see here, if I do that, I'm going to get 2s. And I know equation 3, it has 2s in it. So I'm going to go ahead and do that now. Now, I add it with this equation right here. I get 5r, the s's go away, I get -7t equals 6. Alright. Let's steal and borrow these, shall we? Alright. Now going on, I've got two equations. And I've got two variables. I've gotten rid of the s's, I'm left with r's and t's. So now, this takes me back, takes it on back to where I've done previously, where I've had practice with this before. I've got these two equations right here. So now I've got to figure out, okay, based on these two little creatures, let's solve for a variable. I can solve for r's or I can solve for t's. Take a minute and think about that. What have we decided? Let's solve for t. Let's get rid of t. Okay, imaginary voice in my head, that'd be great. So what I'm going to do is, I'm going to make the t's look the same, multiply the top equation by a 2, the bottom equation by a 7. T's not a bad idea because I already have one being negative, one being positive. Again, there isn't a right or wrong answer to these things, but you really should take your time. Try not to make any errors while doing this. Because if you do, it's going to create quite the experience trying to get back to it and try to fix it. Multiply the bottom equation by 7. That's where I might have some errors. It's me 52r and 196 plus 12. That equals 208. Whew, big number there. I'm going to divide by 52 and get r equal to 4. From there, the problem begins to unravel itself. Man, if only I had an equation that had an r and just one other variable that I could solve for. Oh wait, I do. One of these two up here. Let's go to the bottom one. So started from the bottom, now we're here. I'm going to put that r into my problem. Now when I do this, that's 24 plus 2t equals 28. That's 2t equals 4. T equals 2. Alright, so far so good. So armed with this knowledge, I have R, S, and T. I know that T is 2. I know that R is 4. I don't know what S is yet. I'm going to pick an equation. I'm going to pick the second one to put these values into, simply because it's got a single S there. Does it really matter? Absolutely not. It doesn't matter. You can take your pick. The world is your mathematical oyster there, so to speak. So 16 plus S minus 4 equals 6. That's S plus 12 equals 6. That means S equals negative 6. Now what you could do with these fancy answers is you could in fact test every single one of these points. This is what I would do. Because this equation right here, these three set of points, needs to work in all three of those. Or if you were feeling so inclined, you could write them as a coordinate pair. Alright, let's move on to the next set, shall we? Sure. Okay, let's go to the next problem, shall we? Yes, let us do that. So, let's look at this problem and take a minute and figure out which problem or which variable I wish to get rid of. Alright, which problem is it? Well, got some options here. There really isn't a bad or a good one. So, taking a gander at this, man. I can get rid of the x's, the y's, or the z's. Now, it doesn't matter. You see the x's there have a single x that might be helpful. I just got to multiply by a negative each time. The z's are awfully fancy because I can just add these two equations together. Equations 1, 2, or 2 and 3 here. Then I gotta do a little more work for the third one. Any options? Let's kill off x. Eliminate x. Let's eliminate x. Alright, so that's gonna mean equation 1. I'm gonna keep using equation 2 here. I'm gonna add it to a negative 4 times equation 2. So this is gonna take a little bit to write out. Now again, you want to be very careful with your multiplication step here and make sure that you don't have any foul ups, which means that you want to be very careful when you multiply, making sure that you do sharing is caring. Alright, here's equation 1. Now negative 4 times equation 2. All the signs are going to flip, which makes it interesting when I do this. Good, the x's cancel, that's great. Alright, so now that I have this, I need to do it for another set of equations here. Let's pick, oh, I don't know. Equation 3 plus, well, let's go with a negative 6 times equation 2. So, equation 3 here, no big deal. And equation 3, alright. Now the trick is to not accidentally write down different parts of each problem. Meaning, I don't want to mix match equation 2 and equation 3, or equation 1 and equation 3 together before I actually do all the work. Be very careful of that. The common mistake people make is they go crazy with this and start going at a breakneck pace and don't slow down a little bit and think about what they're doing. Alright, so now I'm going to take these two. How do I know they work? Well, I know I have two equations, two variables. They no longer contain x, they contain y and z. Alright, so let's give this a whirl here. Let's paste it. Now, what variable would you want to get rid of? Think about that for a second while I do some erasing. There seems to be one clear choice to me. Anybody want to shout it out? Oh wait, I'm talking to myself. Oh well. Guess what? I'm going to get rid of the y's. Why is that? Look at that. Get the pun there. Ha! Anyways, I get rid of the y's because if I multiply this one by a negative 1, I realize the y's will change sign. They're both 7s already, which is awesome for me. So let's go ahead and do that here for a second. So keep the top one the same. Alright. Bottom one changes the signs of everything. Add them up and I get negative 11z equals negative 11. Which when I do the division, z equals 1. And just like a thread that you're pulling out of a shirt, once you start pulling one out, it's going to unravel very quickly. Because here, look, if only I had an equation with, oh, you guys get the joke already. I've got z and y here. I'm going to put it in the top one this time because I put it in the bottom one last time. I get negative 14 times that z being 1. That equals 7. 7y minus 14 equals 7. 7y equals 21 when I add it over. Means y equals 3. Alright. So gathering that information, I want x, I want y, and I want z. Well, guess what? I've already found z being 1, y being 3. Time to find out what x is. I'm going to go to the middle equation again, simply because it has a coefficient of 1. Now, truth be told, it doesn't really matter which equation you use. I mean, you could do all of them if you really felt the need to and be super concerned about it. I'm not, because I see that has a coefficient of 1 for the second equation for x, and, well, I'm feeling particularly non-combative towards these math equations today. I just want to get them over with, as I'm sure all of you do at this point. So that's x minus 4 equals 1, x equals 5. Now, what I would highly suggest doing is you should know if these are right or not. You can check yourself before you wreck yourself and check these particular solutions in all the problems. Or, if you were feeling fancy, you can write it as an x, y, z coordinate pair. Okay. Now let's move on to the last problem, shall we? Alright, so here we have this equation. I'm looking to see what I could possibly do with this. Well, I can get rid of the r's, the s's, or the t's. But I'm looking there and I'm going, you know, s is probably a pretty good option as long as I label my equations like I'm supposed to do, because that would be helpful. Why is s a good option? Well, if you look, I can simply either multiply one of the equations by -1, or just add 2 times equation 1 to both equations 2 and 3. Does it really matter how I handle that? Absolutely not. So what I'm going to do is do a little harder way this time. I'm going to do equation 2 plus 2 times equation 1. Equation 2 doesn't change at all, so we can go about hammering this out and be perfectly happy with that. So we go ahead and do that. Now equation 1, I multiply by 2. That's why I write it down like this. Folks, it's imperative you do that, because if you don't, and you're asking someone for help, they're not going to be able to figure out what you multiplied things by, and it's going to create a bit of a hassle and a bit of time wasting, to be honest, for you to tell them exactly what you did. So then now I'm going to take equation 3 and multiply it by 2 times equation 1. Again, I'm allowed, as long as I don't use the same combination, equation 2 and 1 again, I'm allowed to write a new combination out, and this one seems to be the easiest one. Now, I could, truth be told, multiply either equation 2 or 3 by -1 and add them up, and that's perfectly fine. But I told you I was going to do the harder one this time, and I am a man of my word, so we're going to go ahead and do that. So, take a second to do the multiplication here. Now we do this, and I get -8r, s's go away, minus 5t equals 7. Okay, so let's transfer these two equations over. Now from here it should be a fairly straightforward attack of how I want to do this, because I've got some options here. Either I get rid of one variable or the other here in this case. I get rid of the r's or the t's. Now, truth be told, there is a very simple way to do this. If I multiply one of the equations by a -1, I would get rid of my t. See how they're both negative, and I want to add them? But I told you I'm going to do it the harder way this time, and do it the harder way I shall. So we're actually going to get rid of the r's, because I'm crazy. So I'm going to multiply the top equation by 8, and the bottom equation by a -9, because I do still want to add these. I'm not that crazy. Now, like I said, I'm only doing this to show you the harder way to do this. Clearly, if I were doing this the easy way, I would look and go, ha ha ha, look at them, they're both -5t's. I'd multiply one of them, one equation, by -1, and we'd be Bob's your uncle. However, we're not going to do that. We're going to go the harder direction here just to prove a point. Now, on a test or a quiz, would I do this way? No. You definitely don't want to be trying to quote-unquote prove a point that you could do this, because you're going to end up getting yourself in trouble. But in this case, since I can do that, and I believe I can, we're going to give it a whirl. Now, what I get here, the r's go away, I'm left with -5t equals -25, t being 5. Alright, just like a piece of clothing, we'll unravel this. Now, I'll put it in the bottom equation because it's simply what's here. So let's go ahead and do that. -9r minus 5 times the t being 5 equals 11. Now, you don't want to put it in one of these equations, guys. Not you can't, but see how you've increased their value? It's just more work for yourselves. So operate under the least resistance, but even I am doing that this time, because you definitely should not do that yourselves. -9r equals a 36. R equals -4. Bound with this knowledge, I go on to the last part of the problem here. So let's think about this. So I have R, S, and T. I found what T is. It's 5. I found what R is, -4. Take a second and figure out which equation you want to multiply or use these two variables to solve for S, the variable we eliminated in the first place. Alright, I'm going to do the third one at this time because it seems a little more difficult. I don't know what that is, plus I told you I was going to create a little harder problem this time. Alright, so now I put in what I know. Now it's important to remember where things go here. Okay, R, that's a -4. S, I don't know what that is yet. T is a 5. You definitely don't want to put the variables in the wrong order, so take a second and make sure this is right. Okay, yes, T. Yes, R. Yeah, I don't know what S is. You definitely don't want to solve for the wrong variable when you don't have to. Okay, I get -4s minus 1 equals -9. That's -4s equals -8. S equals 2. So now that you have this done, you are clearly able to go on to the next problem, which there isn't one. You're now ready to tackle all the work you need to. Oh, happy days are here again. Now we can do all the mathematics. Yay! Math, 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 math.